Today's problem is longest subarray with majority greater than k. Difficulty medium. I'm rushing a little bit to try and get this in before the end of the day, so I can get a geek bit. The problem is, given an array and an integer k, the task is to find the length of longest subarray in which the count of elements greater than k is more than the count of elements less than or equal to k. Okay, a couple of examples. This one, 1, 2, 3, 4, 1, and k is 2. So we have two elements here that are greater than k. So the subarrays 2, 3, 4 or 3, 4, 1 would work. Those are three element arrays with two of the elements greater than k. If we try to extend it any further than that, it's not going to work. There'll be too many elements less than k. This one's a little too simple. K is 2, everything is greater than 2, output is 4. Constraints, array size, between 1 and 10 to the 6th, 1 million. Array elements, between 1 and a million. K, between 0 and a million. Linear time complexity, prefix sum, hash, yes, that's what we're going to do. So to do something like this, several of the problems of the day recently have involved hash maps and prefix sums. This is kind of similar to, what was it, balancing arrays and consonants. Yeah, I mean, some of the problems are actually sums. Some of them we have to figure out a way to convert it to sums. So in this case, we are going to transform the array into ones and negative ones. So this will give us a prefix sum that tells us if we have a majority of elements greater than k. So the new array will have 4 elements that are greater than k will be a 1. 4 elements less than or equal to k will be a negative 1. We'll have a hash map. It's going to contain prefix sums as we go through that array. Prefix sums will be the key, and the first index at which we saw that prefix sum will be the value. So let me get as much of this in here as possible. We'll walk through an example. All right, so everything is visible there. I can see the array, I can see the code. I need a pen. All right. We probably should, yeah, we're going to want to keep track of the value of I here. I will start out at 0. And let's see, our hash map, we'll keep that over here. We're going to initialize that to 0, negative 1. That's the state before we do anything. The prefix sum is 0, and we're seeing that at index negative 1. I mean, there is no index negative 1, but for the sake of doing the arithmetic here, we're going to set it to 1 less than the first index of the array. So 0 and negative 1. And let's start to go through here. First element in the array is, and actually I should probably write out the transformed array here. That would be negative 1, negative 1, 1, 1, and negative 1. All right, sum plus the transform is going to be negative 1. Is the sum greater than 0? No. If the sum gets to be greater than 0, that means that we have a subarray starting from the beginning of the array to the current index. That is the majority of the elements are greater than k. If the sum is not greater than 0, then we're going to look for prefix sums with a key less than the current sum. Now what is, the current sum is -1, so we're going to look for a key of -2 in the table, and it's not there. So if prefix sums does not contain the key, I'm sorry, does not contain the sum, -1, then we will put it in there. -1 and the current index of I, which is 0. All right, go again. I is now 1. Sum, we will add, we're here now. We will add the transform array, -1, so it goes to -2. Is that greater than 0? No. Is there a prefix sum for -3? No. Is there a key for -2 in the table? No. So we'll put it in. -2, and it is at index 1. All right. Next element 2. I goes to 2. We will add transform at index 2, which is a 1. This goes to -1. Is that greater than 0? No. Is there a prefix, is there a key in the table for -2? Yes. So we got to do a computation here, which is I minus prefix sums get for -2, it is 1. So 2 minus 1, is that bigger than longest? Well, longest is 0, so longest is now going to go to 1, meaning we have a one element prefix, a one element array, 3 subarray, where the majority of the items are greater than k. All right, prefix sums, let's see, sum is -1. If that is not in the table, now it is in the table, and the reason that we don't put it in there if it's already there is we want the longest subarray possible. So we want the first time that we saw that prefix sum, the smallest index, the first index at which we saw that prefix sum. Why? Because we subtract, where is it here? We subtract that value in our calculation of the, we subtract that value here, current index minus the value in the table. So we want the smallest value possible, first time that we saw it. All right, 2. Did we do 2 already? Yes. All right, so I is going to 3. All right, so now we are here, and we add 1. Add 1 to the sum. That is 0. Is it greater than 0? No. Is there a key in the table for -1? Yes. So we need to do a computation. I minus the index that we get from looking up -1. And the index is 0. I is 3. So we now have 3 minus 0, 3. All right. What is that telling us? Well, it's telling us that we had a prefix sum of -1 here. Okay, so if we take that off and keep what's left, we have 2, 3, 4. We have a 3-element array in which the majority of the elements are greater than k. All right, prefix sums. Sum, is there a key in the table for 0? Yes. So we don't add it. Okay, now we're going to go to 4. We are here. This is going to go to -1. Is it greater than 0? No. Is there a key in the table for -2? Yes. We'll do a computation. I, which is 4, minus the lookup for -2, which is 1. 4 minus 1 is 3. That's what we have already. And so we are done. And the longest is 3. All right. Let's take the writing off here and try and run this. Look at that. Get this back. Scoot this over. And let's try it. Okay. I got a geek bit there with like 2 minutes to spare according to my clock. So that's it. It's one of several problems of the day lately where we use a prefix sum and a hash map. Sometimes you have to think a little bit about how can I convert this problem into something with prefix sums, but otherwise the mechanism is the same. So that's it. Please like the video and let's see. Yeah, go ahead and subscribe. I'll send these to you weekdays in your inbox, and we'll see you next time.